I am going to try to work out some of the math problems on the homework for you guys. So you can have just this little walkthrough of how I do them. We're going to start with problem 1. Star A has twice the trigonometric parallax and twice the luminosity of star B. And then part A says, what is the relative distance of the two stars? So anytime you see a problem that's comparing two different objects, this is a ratio problem. And you want to start off by writing down the relationships that you know. So that one is going to be, I know that the parallax of star A is 2 times the parallax of star B. I also know that the luminosity of star A is 2 times the luminosity of star B. And then you want to write down what you don't know. So in this case, for part A, what I don't know is the distance and how they relate to each other. So once you've got your knowns and unknowns, you're going to look at your equation sheet that I'm going to put up on the board for the quiz. And you're going to say, okay, what kind of equation has my unknown and then things that I know? And the equation that you're going to find is going to look like distance is equal to 1 over the parallax. All right, so you've got your unknowns and then something that you know here. So you're going to write 2 versions of this equation, one for each object. So I'm going to write a version for star A. It says the distance to A is 1 over the parallax of A. And one for star B, so that says the distance to B is 1 over the parallax of B. So I've got 2 equations here, and they both have only A's or only B's. But I want my final answer to have both A's and B's, because I want it to have the distance to A and the distance to B in it together. So I want to start looking for a way that I can bring A's and B's together. And the way that I do that is I look and I see this parallax of A, that is equal to 2 times the parallax of B. So I take this equation and I just replace this 1 over the parallax of A with 2 times the parallax of B. So I'm going to take this 2, and instead of dividing by 2, I'm going to multiply by 1/2. So I've got 1/2 times the parallax of B. And now I can see that this 1 over the parallax of B is the same as the distance to B. So I can replace that with the distance to B. And now I've got my relationship that I'm looking for. I have the distance to A is 1/2 the distance to B. So part B says, what is the relative brightness of the 2 stars? So I know, that the luminosity of A is 2 times the luminosity of B. I know that the distance of A is 1/2 the distance of B. What I don't know is the brightness of A or the brightness of B and how they relate to each other. So this I, this is brightness. So I'm going to look on my equation sheet. I'm going to look for something that has things that I know and things that I don't know. And you're going to get an equation that looks like brightness is proportional to luminosity over distance squared. So I'm going to do 2 versions of this, one for each star. Brightness of A is proportional to luminosity of A over distance to A squared. Brightness of B is proportional to the luminosity of B over the distance to B squared. So now I can see here, this luminosity of A is the same as 2 times the luminosity of B, and this distance to A is the same as 1/2 times the distance to B. So I can sub in the brightness of A proportional to, for luminosity of A, I'm going to sub in 2 luminosity of B. And for distance to A, I'm going to sub in 1/2 the distance to B. So now I have this squared here. And I need to distribute that to every term inside these parentheses. So that's going to give me 2 times the luminosity of B over 1 squared, 2 squared, distance to B squared. So that's 2 luminosity of B over 1 over 4. 1 squared is 1, 2 squared is 4, distance to B squared. So here, instead of dividing by 1/4, I'm going to multiply by the inverse. So that is going to be 4. So here down I've got brightness of A is 8 times the luminosity of B over the distance to B squared. And I can say that this is equal here to this. So that gives me 8 times the brightness of B. So I get the brightness of A is 8 times the brightness of B. Okay, and that is problem 1, the ratios. So the other ratio problem in this is problem, let me see, it's like 23. So this says, how long will a star with 10 times the mass of the sun and 10,000 times the luminosity of the sun spend on the main sequence of the HR diagram? So I've got, my knowns are that the mass of this star is 10 times the mass of the sun. It's this symbol, right? Sun. The luminosity of this star is 10,000 times the luminosity of the sun. And then another thing I know is that the time on the main sequence for the sun is 10 to the 10 years. And my unknown in this problem is how long will this star be on the main sequence? So that is time on the main sequence for this star. So I'm going to look for an equation that has mass, luminosity, and time on the main sequence. And it's going to tell me that time on the main sequence is proportional to mass over luminosity. So I'm going to do my 2 versions. Time on the main sequence for this star, proportional to mass of this star over luminosity of this star. Time on the main sequence for the sun is proportional to mass of the sun over luminosity of the sun. Now I'm going to do my substitutions for this star. Got that the mass 10 times the mass of the sun and the luminosity is 10,000 times the luminosity of the sun. So I've got 10 times the mass of the sun over 10,000 times the luminosity of the sun. Now I'm just gonna cross off one of these zeros and say that instead of dividing by 1,000, I'm going to multiply by 1 over 1,000. Mass of the sun over luminosity of the sun. And then this here is the time on the main sequence for the sun. So I've got the time on the main sequence for this star is equal to the time on the main sequence for the sun. Instead of multiplying by 1 over 1,000, I'm going to just divide by 1,000. And that is 10 to the 10 years. 1,000 is 10 to the 3. If I'm dividing something in scientific notation, then I subtract the exponents. So this is going to be 10 to the 10 minus 3 years. So that gives me that the time on the main sequence for this star is 10 to the 7 years. And remember to put your units always.